Welcome back to my channel. We are continuing our sequence of integration, and today we are dealing with the following problem. We have the structure of polynomial multiplied by exponential, and we'll use integration by parts to solve this integral, because it's generally hard to compute an integral of multiplication of two terms which have an x dependence. So we'll try to reduce one of them. In our case, it's a polynomial, because by differentiating it, we can reduce this to a constant function, and in the end, we'll deal with the integral of e to the kx only. As I said before, I'll use integration by parts, and what we will take as our functions is we'll take the polynomial as f and the exponential as g prime. We do this because we'll need to differentiate the polynomial to reduce its degree. What we have here is, let's write x squared minus 2x multiplied by integral of e to the kx. What's that? Exponential does not change its structure under integration nor differentiation, so it's e to the kx, but divided by k, so that when we differentiate it, we have e to the kx, because e to the kx derivative will be k times e to the kx. Okay, minus integral of, we now already have e to the kx over k in our hands, so let's just write it, e to the kx over k, and we multiply this by, let's move this all to the left a little, we multiply this by the derivative of f, which is 2x minus 2. So let's write this down. It's 2x minus 2 dx. So what we get is, we have x squared minus 2x e to the kx over k minus, let's write this down as like 1 over k integral of e to the kx 2x minus 2 dx. So again, we have a structure of exponential and polynomial, right? But this time its degree is 1. See? And we want to reduce it more, because still we have an x dependence. We'll take now, again, e to the kx f g prime, or f prime, and g. What we have here, again, x squared minus 2x e to the kx over k minus 1 over k. Let's open the brackets. Now here, what we have, first we'll just write 2x minus 2, because it's just a function g, and multiply this by the integral of our f prime, right? As we said before, its integral is e to the kx over k minus integral of, again, we just repeat e to the kx over k, e to the kx over k, and multiply this by the derivative of our function g, which is 2 dx. Okay, now as you may observe, we get e to the kx as our integrand, and this was our initial aim actually. So let's rewrite our result, and I'll try to write the final answer directly. We have x squared minus 2x e to the kx over k minus, so here we have 2x minus 2 e to the kx over k squared, right? Then we have, now we are dealing, just for the reference, we're dealing with this term, and it's equal to plus, so let me write it here. This is equal to 2 over k, like minus 2 over k, integral of e to the kx dx, right? So we just keep this in our minds and try to multiply by minus 1 over k. So I have 2 over k squared, integral of e to the kx is, let me write it here as well, minus 2 over k e to the kx over k, right? And to write this as our final answer, it's k cube e to the kx. So here, instead of k squared, we write k cube e to the kx and plus some constant c. This is our final answer. Let's write it. Let's mention it like this. So here we are. I'm deleting these parts because it's not as necessary, and we are done. If you have any questions, feel free to ask them, and see you on the next videos.